What's good, YouTube? It's your boy Zach, the Codeaholic, and I'm back here with a video. So today we're going to be doing this problem, maximum depth of a binary tree, or for those of you who know, depth first search. So let's go ahead and read the description of this problem. So, given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node to the farthest leaf node. Basically meaning you have levels. So this would be level 1. This would be level 2 where my mouse is, and this would be level 3. And that is depth first search. It's recursively finding the depth of the tree, pretty much going downwards, not outwards. So here we have an example, 3, 9, 20, 15, 7. So here we have the root node and its leaf nodes right here. So the child nodes 9 and 20, 15 and 7. So we have the input, which is the tree itself. Then we have the output, which is 3. So, as you can see here, this is how it would read. So 3, 9, 20, null, null, 15, 7. So we have 3 here with the child nodes of 9 and 20. 9, 20, null, null, not to be confused. Because I know a lot of people see null and think, well, where is that at? Because then you see 15 and 7. Null is here to represent the childs of 9. So it would be null here and null here. And then it would go to the child of the next node, which would be 20. And you'll see 15 and 7, which are both child nodes. So, as you can see, that would be 1, 2, 3. That's pretty much the output. This is how you kind of think about it as like a brute force solution. You're working yourself downwards. If another path exists, you'll return +1, meaning that there is another floor that you have to go through, and you would solve this problem recursively. So this is very common data structure algorithm that is taught. This along with breadth first search, which is instead of going downwards, you're going outwards. So it'd be how far outwards you can expand versus downwards. But since we're doing depth first search, we won't worry about that. So if you look at the constraints, the number of nodes in the tree in the range from 0 to 10 to the 4th power, basically saying that, our tree could be gigantically huge. Alright, so getting started with this problem. When tackling problems like this, you always got to think about just, looking at the problem, think, what do I need to do? How would I solve this? What would be the easiest way for me to solve this right now? Like, what would be the easiest way? Okay, yeah, you're going to go down, down again. And basically, if another child exists, you will just add 1, right? So, the best way to do this is to do it recursively. So, let's say we'll have a function, max depth, that we'll call on, that will be receiving a root. So, the first thing we want to check is if the root exists. So, say the root does not exist, then we will return 0. Meaning that the root that's given is null. Because if it doesn't exist, we're not going to add it to the top, or we're not going to add it to the count of how many levels we're going through, because we want to get the level, the maximum depth. If it's null, it won't count towards that maximum depth level. So we have a tree, we have a left and right node, so then we need to call the recursive function on that left and right node to recursively call it. So we'll go ahead and do left, but left is equal to max depth of root dot left. So basically calling the same function and setting it to the left variable of the left child node of the root that we're on currently. And it will recursively do the same thing. So then we'll do the same thing with the right. So let right is equal to max depth root dot right. So now we have those two, and they will be going recursively. And now what we need to return is the level, which would be max, or math.max of the 2 plus the base level, which would be 1. So for those of you who might be a little bit confused here, let me just walk you through it. So let's say we have 3. So first thing it's going to do is check to see if 3 is a valid node, and it's not null. So it's not null. So we're going to keep going. So we're going to get the left one, which is 9, and the right one. So now we're going to get left and C and set it to 9, and then we're going to go back in this function because it's recursively calling itself. So then you'll have 9 here. It'll go down. You'll see there's no left and there's no right because it's equal to null, right? Or it will set those nodes to null. So you pass in the 9, and you pass in the left and right of 9, which are both null. So it'll be max depth null, and then it will go and see that those do not exist, therefore returning 0. So basically you wouldn't have to worry about those because it would return null, therefore returning 0, meaning it won't add any numbers to the sum of the depth. So now let's see, we're going to 20. So you pass in 20, and then you pass in the left and right of 20, which are 15 and 7, and you keep those levels 15, 7, and then you have the level of where it's at in the tree, and then you'll add 1, and that's what it's returning. So at the end it will return the maximum depth. So if we can go ahead and solve the problem here, our answer is correct. It beats every case, 39 out of 39. So basically, once we pass in that 3, the 9 and 20 are then passed in. 9 is null, so then 20 is left. 20 goes in, passes its child nodes 15 and 7. You see it's therefore done there, and then at that level you'll have 3. So basically, you pass in the 3, you're at 1. You pass in the 20, you're at 2. You pass in the 15 and 7, you're at 3, and that's what that returns. So if you guys like this type of content of me explaining my LeetCode problems, my LeetCode journey, because they are a lot of hard problems, and you guys want to see more content like this in the future, make sure to hit that subscribe button, leave me a comment, see what you guys want me to post. I can post my coding projects, stuff like that. I'm a recent Texas Tech graduate, so I'm on the urge of finding a job. If you guys would want to see me document that process, that's fine too. But yeah, thanks for watching, and I'll see you guys next time.